Hello again, dear grade 10 students, and here we are going to talk about the last part of our trigonometric functions chapter, and this is the part of associated arcs, and we're gonna start with the supplementary arcs that are related to pi. So supplementary is usually a word that's related to 180, which is equivalent to pi. But before that, let's make a little activity. Let's stop a little bit, hold our calculators, and press sine 30 and cosine 30. So please, on your calculators, for a meanwhile, press sine 30 and cosine 30 and then note down your answers. Then again, press sine of 150 to get an answer, and then cosine of 150 and note down your answers, and similarly for the sine and the cosine of 210. Let's wait for a meanwhile. Let's get the answers. I guess that you all got the same result, that sine of 150 is half and cosine of 150 is minus radical 3 over 2. What does that have to do with 30? Let's see. Let's remember that sine of 30, using the table we talked about previously, is half, and I guess we proved it using the semi-equilateral triangle. And cosine of 30, I guess all of you got this answer. It is radical 3 over 2. And now let's make a little comparison in order to discover the rules. So sine 150, which is from the family of 30, it's a supplement of 30, so it is sine of pi minus 30, which is 180 minus 30 as well, is given to be half on the calculator, which is exactly equal to sine 30, while cosine of 150 were minus radical 3 over 2. The calculator gives the answer of minus radical 3 over 2. And 150 is indeed pi minus 30. So I can notice that cosine of pi minus 30, replacing 150 by pi minus 30, which is 180 minus 30, is negative radical 3 over 2, which is negative cosine of 30, because cosine of 30 is plus radical 3 over 2. And note that pi minus 30 is in quadrant 2. So this is what happens with 150. Let's see what happens with 210. I guess that you got this answer also. Sine of 210 is minus half, and cosine of 210 is minus radical 3 over 2. So for 210, both sine and cosine are negatives. Why? Because 210 is indeed pi plus 30, 180 plus 30. And again, cosine of 210 is cosine of pi plus 30. And as you know, pi plus 30 is in quadrant 3. And in quadrant 3, the sine and the cosine are negatives if related to this angle, which is the initial angle 30. So again, sine of 210 is the opposite, is negative sine of 30, and cosine of 210 is negative cosine of 30. And again, recall that 210 is represented by pi plus 30 and 150 is represented by pi minus 30. Why am I recognizing these? Let's see why in the next slide. Here come the rules. For supplementary arcs or angles that are related by pi, which is equivalent to 180 as well, let x represent an acute angle. Then we have, so now we are going to talk in general, not just for 30. We saw an activity concerning 30, concerning pi minus 30, and concerning pi plus 30, and now we are going to talk in general in order to represent our discoveries by rules. we noticed that sine of pi minus x, for example for 150, it kept the same sign as 30. Signs didn't change. Sine of 30 were half, and sine of 150 is half too. So sine of pi minus x is exactly equal to sine of x. And cosine of pi minus x is minus cosine x, so definitely tangent of pi minus x is minus tangent x. Let's see it on this circle. Here is the acute angle x in quadrant 1. Now pi minus x, that blue one, is in quadrant 2. And all of us know that all students take chemistry. So in quadrant 1, all are positive. In quadrant 2, sine is positive. In quadrant 3, tangent is positive. And in quadrant 4, cosine is positive. So pi minus x is in quadrant 2. In quadrant 2, the sign is kept positive, while cosine is changed into negative. That's the interpretation in general. Now, what about the other rule concerning pi plus x? Sine of pi plus x is equal to minus sine x, and cosine pi plus x is equal to minus cosine x, while tangent of pi plus x is equal to plus tangent x. It's kept as it is. So sine and cosine are gonna be negatives because pi plus x is in quadrant 3. And in quadrant 3, only tangent is positive and the others are negative. So to sum up, whenever I have sine of pi minus alpha, or pi minus x, or pi minus beta, and similarly for cosine, I just specify the quadrant where pi minus alpha belongs to. So I move in the positive sense, and I'm sure that pi minus x is in quadrant 2, and then I apply the rule of all students take chemistry. I remove pi and I keep on writing sine or cosine of x and alpha or beta or whatever according to the variable here, to the letter here, and the signs are according to which quadrant we are talking about. Now we are going to talk about complementary arcs that are related by pi over 2. Again, there is an activity. I want you again to hold your calculators and to find sine of 30 and cosine of 30. Then I want you to find sine of 60 and cosine of 60. Then I want you to find sine of 120 and cosine of 120. I'll wait for a meanwhile. Please find them using your calculators and note down your answers. Okay, let's see what we get. Sine of 60 is radical 3 over 2, which is indeed cosine of 30. So let's write again, sine of 30 is half, and cosine of 30 is radical 3 over 2. But using the calculator, we notice that sine of 60 is radical 3 over 2, which is cosine of 30. So we notice that sine of 60 and cosine of 30 are the same. Okay, what does 60 represent for 30? 60 is 90 minus 30, which is represented as pi over 2 minus 30. Similarly, for cosine 60, when pressing cosine 60 on the calculator gives half. So cosine of 60 is half, which is sine 30. Then we notice that 60 and 30 exchange sine and cosine, and that remark was mentioned previously, that complementary arcs whose sum is 90 exchange sine and cosine. And note that pi over 2 minus 30 is in quadrant 1. That's why the sine and the cosine are positives, because in quadrant 1 all are positives. Let's continue. What about 120? Sine of 120 using the calculator is also radical 3 over 2, which is again cosine of 30. Cosine of 120 is minus half, which is minus sine of 30. So again we notice that 120 and 30 exchange sine and cosine, but here the cosine is negative because pi over 2 plus 30, which is 120, so 120 is indeed 90, which is pi over 2 plus 30. So because 120 is in quadrant 2, then definitely the sign is positive, is kept positive, while the cosine is the same as sine 30, but we have to put a negative sign beside it. So what can we conclude? Let's see. We can conclude that according to complementary arcs, and if x represents an acute angle, then we have that sine of pi over 2 minus x is equal to cosine x. So sine of pi over 2 minus x, when the angles are related by pi over 2, then they are called complementary angles. So they have to exchange sine and cosine. Then sine is gonna be cosine, and cosine of pi over 2 minus x is gonna be sine x. Okay? So where is pi over 2 minus x? As you see, it is the pink one. Here is the acute angle x, the green one. The pink one is pi over 2 minus x. It's indeed in quadrant 1. That's why both have a positive sign. Also, sine of pi over 2 plus x is equal to cosine x, and cosine of pi over 2 plus x is equal to minus sine x, because pi over 2 plus x, as you see here, is in quadrant 2, and in quadrant 2 the sine has a positive sign, but it's going to be cosine, because again and again when arcs are related by pi over 2, which is 90, then we have to exchange sine and cosine. So sine goes to cosine, and it takes the sine of sine. So in quadrant 2, all students take chemistry in quadrant 2, sine is positive. Then sine of pi over 2 plus x is equal to plus cosine x. And similarly, cosine pi over 2 plus x, cosine will go to sine because they have to exchange. But since pi over 2 plus x is in quadrant 2, and the sign of the cosine in quadrant 2 is negative, then we put minus sine x. And these are the rules to sum up the relation between trigonometric functions for complementary arcs. Here we go with the last idea concerning opposite arcs and another activity. Also again, hold your calculators and press sine 30, then cosine 30. Note down the answers. Of course, you will get half and radical 3 over 2. Press sine of minus 30 and cosine of minus 30, and let's see what you get. Sine of minus 30 will be given by the calculator by minus half, which is minus sine 30. And cosine of minus 30 is given by radical 3 over 2, which is the same as cosine 30. So again, we are going to get the same values. They don't exchange here. Sine of minus 30 is the same as sine 30, but there is a minus sign beside it. Cosine of minus 30 is the same as cosine of 30 exactly, because minus 3 is in quadrant 4, and in quadrant 4 cosine is positive. So as you see here x is represented by the green color, and minus x is in quadrant 4. So since all students take chemistry, in quadrant 4 cosine is positive as you see here, and sine is negative. So the rule says, in general, if x is any acute angle, then sine of minus x is minus sine x, and cosine of minus x is kept as cosine x. And these are called opposite arcs, minus x and x, or opposite angles. So to sum up, here is a summary for everything we said. So first of all, for supplementary arcs that are related by pi, sine pi minus x is equal to sine x. Cosine pi minus x is equal to minus cosine x. And remember, pi minus x is in quadrant 2. In quadrant 2, sine is positive, cosine is negative. So tangent is also negative. So as if we are removing pi, we are satisfied with x, but we just care about the signs. Again, sine pi plus x is minus sine x, because pi plus x is in quadrant 3. So again, here we are in quadrant 2. Here we are in quadrant 3. In quadrant 3, sine is negative, cosine is negative, and tangent is positive. Okay, let's continue rules. And here is the circle representing the acute angle x. In the second quadrant we have pi minus x, the blue one, and in the third quadrant we have pi plus x, the pink one. Now these are rules for opposite arcs. So sine of minus x is minus sine x, because minus x is in quadrant 4. Then the sine is negative, the cosine is positive, and the tangent is negative as well. And here is the circle. Here is x as you see, and here is minus x in quadrant 4. And finally, here are the complementary arcs that are related by pi over 2 corresponding to 90. Sine of pi over 2 minus x is equal to cosine x. So again, in case we have pi over 2, we have to exchange sine and cosine. So the sine will be going to cosine. And pi over 2 minus x is in quadrant 1, then all are positive. Cosine of pi over 2 minus x is going to sine x, and tangent of pi over 2 minus x is going to cotangent x. Also, for pi over 2 plus x, which is in quadrant 2, sine of pi over 2 plus x goes to plus cosine x, because in quadrant 2 sine is positive. Cosine of pi over 2 plus x goes to minus sine x, and tangent of pi over 2 plus x goes to minus cotangent x. And here is the circle representing these arcs. Here is the green acute angle x. The pink one represents pi over 2 minus x, which is, as you see, in quadrant 1. And the purple one represents pi over 2 plus x, which, as you see, is in quadrant 2. And this is, to sum up, all about associated arcs.